Hello, Coach Travis here with another pre-calculus video. So this is a video about graph transformations. So the idea is that we're given the graph of some function, and it's this dotted function here. And we don't know, we're not given the formula, so I have no idea what the formula for this dotted function is. But then what they want me to do is they want me to make a prediction about what the graph of this whole complicated thing here is going to be. So the idea is this whole complicated thing is just a transformed version of our original. And so if we know what the graph of the original looks like, then we should be able to predict what the graph of the transformed function looks like, even if we don't know any formulas. So that's what I think is neat about these problems, is we don't have any formulas, but we do have the graph. And it turns out knowing the graph is enough to be able to make these predictions. Okay, so the first thing I always like to do in problems like this is I want to line them up. So the idea is I have control over the solid function, and that's going to be where I want to put my final answer. But before I do anything, I want to start with it being on top of the original, because I want to think about the thought process is I want to apply transformations to this function in order to get to this function. So my starting place is the original function. Okay, so that's what we got. And now, so now I want to work from the inside out and apply these transformations graphically. So, all right, so if I work from the inside out, and so the first transformation is the x turns into an x plus 4. And so we know that if your x turns into an x plus 4, the graph transformations tell us that that's going to be a shift in the negative x direction by 4. It's going to move all the x coordinates to the left by 4. So, all right, so I just took that and moved everything over by, all the x coordinates got moved over by 4. And now, now let's see, now it's a tricky one, because this is, whenever you multiply on the outside, that's going to be a scale, that's going to be some sort of scaling. So when you multiply the outside by a number, what that's going to do is that's going to stretch your y coordinate by that factor. So all of our y coordinates are going to get multiplied by a factor of 3. Okay, so this might be a little bit tricky here, because that's going to take me off of the screen. Because the only points I can control are this one, and this one's not going to move, because this point has y coordinate 0. And if you multiply 0 by 3, you're still 0. So this point isn't going to move. This is the point that's going to move, but it's at height 4. And if I multiply it by 3, that's going to take it out to 12, which I can't. It's going to be off the screen. So I've got a little bit of a problem. So why don't we? I'm gonna making mistakes is part of learning. So let's try to start over and see what we could do that would work better. The problem is that this point's too high. This point's too high. It's because it's way up at y coordinate 4, and so when I try to multiply it by 3, it's going to be off the screen. So if I look at my graph carefully, I see, well, I think I could actually probably take this point and move it down to right there. I can move it down to height at 1. So the graphs still line up, but now this point's much lower, so it'll work better. So all right, so cool. So we learned from our mistake. So we didn't do anything wrong before. It just the way the game was set up, it just wasn't working right. So all right. So first, what we want to do is we want to do that shift to the left by 4. So 1, 2, 3, 4. Okay, and now we want all the y coordinates to get multiplied by 3. So right now this has y coordinate of 1. So I'm going to move it. If I multiply 1 by 3, I get 3. So I'm going to move that point up to now have, I moved it too far. I'm going to move it so it now has y coordinate 3. And note the x coordinate didn't change. The x coordinate also happened to be 3, negative 3. But that was just kind of a coincidence. The real point was that the 1 turned into a 3. It got multiplied by 3. So all right, so we got that transformation. And then the last one here says we subtract 3. So if you have a subtraction on the outside of your function, what that's going to do is that means all y coordinates go down by 3. So all of these points are going to move, and they're going to move down by 3. And all right, so I was at y coordinate 0, and I moved down to y coordinate 3, and this point that was at y coordinate 3 is now at y coordinate 0, so that seems to be doing what I want. So I think we got all our transformations accounted for here. So I'm ready to press the submit button and check that worked. All right, and sure enough, that's how it goes.